flow engineering, to some extent, we just talked about that because what we're doing with value stream mapping has a lot to do with flow engineering and especially the future state engineering. You're going to have a number of topics that, like I mentioned, you may need to bring in experts on certain areas if you decide something's a bottleneck or an area that needs to be improved. There are a lot of technology areas across a value stream, and sometimes you may need to bring in, an expert. Let's say you need to improve your version management system, so you want to bring in somebody that really understands how to do that, what the possibilities are. In general, version management is critical to software security. You want to keep track of the configurations of the source code and the output of the builds, the artifacts and release components and configuration as code. So those should be tracked consistently, reproducible. And if you're not doing that, it can create bottlenecks. It also can increase risk if you're not managing the merged versions very well. You could accidentally bring in a version that could cause damage, or maybe a malicious version that somebody created to hurt your organization. That would undermine the integrity. So version management is one of those fundamental things. If you've got weaknesses in your version management system, that's typically one of the first areas that you're going to try to attack and improve. So code versioning, artifact versioning, configuration versioning, I just mentioned that. Anything that needs to be versioned. In general, you want everything to be versioned because if you have a problem, you may need to back up to a prior version, and you can't do that if you don't have a great, good working version management system. Okay, and risk management as well is a whole topic unto itself. That's obviously related. It's crucial because it ensures, that you're focusing on the right kind of threats and vulnerabilities that are most likely to be a concern. And if you're not, they can definitely impede the flow of software delivery or cause problems with the outcomes. Common flow constraints could be linked to poor risk management. Manual risks processes could slow down things. Overloaded security teams where they're not available to do risk management, that could slow things down. Lack of visibility on the risks that are known could cause problems in the sense that you may not be focusing on the things that are most important. Or excessive risk aversion, right? There's always going to be some risk, so it's always a balance. And if people, get stuck on something that's not that critical, it can still cause delays. So risk management systems are important as part of, it may be something you need to improve when you're talking about value streams. Identity and access management is fundamental to pretty much any software system, but certainly DevOps pipelines, as well as applications and even the infrastructure. So pretty much all the aspects of DevOps. The permission and credentials are all critical and fundamental. It governs how users, systems, and processes access resources within a pipeline. The challenges of integrated access management and DevOps, flow engineering, because you've got a lot of things to manage. Some people will, depending on how you set it up, it can be a challenge to keep track of all the credentials for the many different tools. You want a more of an integrated solution. You might have policies that are too restricted, so that slows people down, hinders productivity. You don't want to have people logging into every separate tool separately while they're working on a pipeline. I've seen that happen. It's really painful to watch. The complexity of the IAM systems can create administration burden. Let's say you have to change passwords and you have to do it n times, where n is the number of tools. So you need something over and above that to manage it. Secret sprawl, where you've got hard-coded credentials and scripts and repositories, is a big no-no. It seems obvious, but I can't tell you how many times I've seen that. And it's like people just get, I think, lazy and build it in, and then they find out later that's a big, bad thing for secrets management point of view. Secrets management, this is the topic here. So in terms of secrets management for DevSecOps, we're just talking about anything that's sensitive, right? It could be credentials, it could be anything that you want to keep secret, right? It could be different keys, tokens, passwords, any other confidential information that you want to protect from unauthorized access. Could even be intellectual property or certain, company secrets. A lot of the times companies, keep secrets instead of patenting things. Nobody should know those secrets, basically, is the proper approach. Instead, you have indirect access to secrets through systems such as The vault system from Terraform is a good example, but there's others. Only authorized people should have the keys to get to them. The secrets themselves should be dynamic and not constant, so they change, kind of like a one-time key type of deal. Make the secret a variable that's pulled from an artifact, again, not directly accessing secrets. Have them rotated or on some kind of schedule. Least privilege for secrets store access, so make sure you're managing privileges, and the people that have levels of privileges should be according to what's appropriate. Not everybody gets the same level. Don't hard code secrets again. The life cycle of the secret itself should be auditable, and make sure they're all encrypted and accessed indirectly through privileged access. Encryption is related to this, so encrypting data, any key data important for value streams that is needed to operate the pipeline. So to ensure sensitive data like credentials, if you're communicating credentials or communicating sensitive application data or customer data, needs to be protected during transit when they're being transmitted to some other place or at rest throughout the pipeline. So if it's sensitive data, no matter where it is, basically it should be encrypted. Know your targets, where's it going? Why? Because if you send it to the wrong place, it can be a bad thing. I've had some embarrassing examples where I accidentally have sent sensitive information, even outside the company, because of silly errors. It was my own fault. I immediately contacted the people I sent it to get rid of it, but it can be embarrassing. So anytime you're sending to a target in transit or data points for interaction, make sure you know who you're sending to. That's maybe one of the first rules. I think that comes with the quiz, by the way. Ensure encryption standards are kept up to date. So you may change your standards from time to time. It seems like every so often there's an announcement, hey, there's this new encryption standard that's unbreakable. And then about a year or two later, it's like, oh, we figured out how to break it. So you need to change your standard. So be aware of that. Keep your encryption standards up to date. Use data classification to define intellectual property. So not all secret things are necessarily the same level of sensitivity. You should have some classification. I remember one company I worked with, we dealt with a lot of secret information that we had to color coding. I think it was 6 different levels. And if you got caught with a orange document on your desk after you close your, even if it was behind a locked door, you got in big trouble. It was supposed to go into a vault because they were super sensitive. I actually have seen entire offices emptied out because of that. The security staff would walk around and do audits and find a secret document sitting on a desk, and they literally shut down the office of that person and ended up having to have a lecture before he was allowed to work again. Understand the risk and apply it accordingly. In general, you should be aware of what the risks are. Implement encryption at rest and in transit. So we already said that. Use digital signatures to be able to operate the encryption and decryption. Artifacts used to encrypt should be stored securely. So